So SolarWinds is an American company that develops software for all kinds of businesses to manage the networks, the systems, and their infrastructure, and particularly, of course, the IT infrastructure. So that's from Wikipedia. I looked it up on their own website, and it was a lot more verbose, a lot more wordy. So I took this one. They have an impressive list of tools available, and for the most part, these are tools that everybody who's in IT needs for what is called OAMP, Operation, Administration, Maintenance, and Provision, of any kind of network devices and of servers. And why is that the case? Well, because data centers have grown today. 20 years ago, if you had 20 servers, that was a halfway decent data center, and it was considered good enough for running your own internal IT. Today, I mean, even a small company such as Axiado, we have close to 100 servers, and data centers today, they're in the range of thousands, if not hundreds of thousands of servers. And so therefore, you cannot manually administer them at all. And that has been the case for over a decade. Because think about it, if you've got 100,000 servers and you need to do something, and every single time it requires you to log in, to provide a username and password, to make a change and then update, let's say, the firmware or do this or that, it has become physically impossible. So if you've got a data center that is big enough, you have to have another data center just to manage your data center, right? So you need an OAMP center, which usually is called NMC, a network management center, to manage your data center. And so that's why these tools are important. You need to know what the servers do. You need to be able to provision them once a new one comes in. You need to be able to maintain them. You need to see if something goes wrong, like a disk is failing, stuff like that, usually proactive. Do you exchange them? All kinds of stuff. So this operation itself has become a data center. So all of the OAMP centers have become a data center by themselves, just to make sure that you can manage your data centers, right? And SolarWinds has a very impressive set of tools for this. And I've used most of the tools. And I know that they put a lot of effort into making them user-friendly and making them relatively, at least, as safe as they can to make sure that the intended purpose can be achieved. So that's a little bit of background on SolarWinds. Let's go to the next slide and then see what exactly the scope of their tool set is. It's network automation, performance monitoring, bandwidth analysis, manage configs, you manage IP address management, you basically manage also all of the switch ports. So if there's something that is required from you, like legal intercept, when the NSA comes with a legal intercept request, you got to be able to do that. And so that's why this is there too. Voice over IP monitoring, troubleshooting tools to see where something goes wrong. So this is only for the network automation. They've got a list like this for every single topic that there is. And they have a total of, 50, 60, 70 tools available. And they're doing a pretty good job. So, I'm not putting blame on SolarWinds for the attack. And you'll see why that is the case and how. Go to the next slide. And then we'll see how the attackers did background research on how to find out how to penetrate networks, independent of whether the networks themselves were easily penetrable or not. So this tool set that SolarWinds has is intended to help system and all the network administrators not only deploy the infrastructure and troubleshoot it, but also probe and change, like, for example, firmware updates, right? Now, the problem is if you allow a tool set to do firmware updates to your data center, you have to provide the tools all of the passwords that are needed to update the firmware for the servers. And that's exactly where the trouble begins. So you have a tool set on a set of servers managing a larger set of servers. And in order to do that, you need the highest level of privilege for all of those servers to execute all of these crucial functions that help you maintain the data center. Go to the next slide, we'll get to that. So Trouble in Paradise came about because of the fact that you need a data center to manage data centers. All of these OAMP tools run on Linux. There are a few others that run on Windows. That's not the case for SolarWinds. But if you look at the world of OAMP tools, most of them run Linux. On SolarWinds, everything is Linux. So they are deployed from a set of servers that manage not only itself, but also the user servers and the tenants. Because if you think of a data center, AWS, Google, whatever, you can rent compute power. That means Google owns and administers the servers, but you are a tenant on a set of servers, on a subset of their servers. That all needs to be managed, right? So for all of this to occur, you need the highest level of privilege that there is to manage the servers, the operating systems on the servers, and the hypervisors, and the tenants' infrastructure that you have rented out to the tenants. So they're not called clients, they're called tenants in data centers, right? And because a data center consists of more than just servers, usually you will find a lot of switches, there will be quite a few routers, and you will find a bunch of firewalls to allow access from the outside into the server. All of that is managed through those OAMP tools. And so these tools now have the administrator's username and the passwords for every single thing in the data center. Everything. Now, if you look at how a server is built today, usually you don't log in through the server itself, through the admin shell. You log in through what is called a baseboard management controller. That is effectively a PC inside the PC that helps you administer the server. And all of the industry standard x86 64 servers today have a BMC, a baseboard management controller. Go to the next slide, please. So the baseboard management controller, or short BMC, is effectively a PC inside the PC or inside the server. And if you look at any of the BMCs that are in use today, they're based all on ARM processor cores. And at the time that they were developed, ARM was not at a stage at which it is today with regards to performance and security. All of those BMCs run Linux or variants thereof, and unfortunately, not particularly new versions of Linux. And the BMCs have full access to the server and every single one of its components. And on top of that, because it's an administrative tool, it has access to the server's firmware and its own firmware to be able to update the firmware in case something hit the wall when you deploy the server. Now, that's really part two of where Trouble in Paradise originated. Go to the next slide, please. So the BMC communication always assumes that there is a VPN tunnel, so a secure link between the NMC and the data center. Therefore, because of an assumption that was made, there is no additional security in the BMC to identify possible attacks. So now you're left with a situation in which an assumed level of security exists, when in reality there is none. So you can span a VPN, which is secure between your NMC and your BMC and your data center, but it doesn't mean you cannot be penetrated. And I'll come to how it all occurred and why there was a problem that led to the fact that all of this was able to be exploited because of inherent assumption of security. Okay, go to the next slide. So if I were an attacker and I needed access to every data center that I want to penetrate, here's the scenario I would use, right? We have just learned there is OAMP software available in an NMC to administer data centers. So that's what I would use to attack a set of data centers, because then I don't have to do it myself for every data center. I just need to penetrate the OAMP, right? And if I penetrate the OAMP software, I now have access to everything. I'm using the OAMP software to attach myself to the BMC. I now penetrate the BMC, and then I can do whatever I want. And the most malicious attack would be to modify the firmware of the server and the firmware of the BMC for each server automatically using the OAMP tools to install, let's say, a backdoor into that server that would either allow access through whatever means I want, or I let it exfiltrate passwords and usernames for everything that is on the server, so I have access to it. Either way, if I do it right, I have access to your server and you will never notice it. And on top of that, because now you have access to the firmware, you can disable any logging function on the server, meaning there is no trace of you penetrating the BMC and then the server. And you can even disable all firewalls, because most firewalls today are based on standard x86 servers. And that now means you use the same mechanism that you use to penetrate a server to penetrate the firewall, and simply disable the firewall. And you can do that from the BMC, and the user of the firewall won't even notice that the entire thing is disabled. Okay, next slide.
One second. So actually, at that point, you're also able to collect secure keys that.
Oh, yes, everything.
So everything. The fact that we have an encrypted security and encrypted communication means nothing. You own the server and all the data on it is yours.
Correct, because even if you've got a salted list of passwords for other stuff, for secondary data, for applications, it doesn't matter, because even the salted hash and the salted passwords will have, of course, a master password somewhere, which you can now steal. So it doesn't do you any good if you really encrypt anything anymore, because you have access to everything.
Alex, could I ask a question before you continue?
Yes.
You know, to make an analogy to an earlier technology kind of interval, databases had similar kind of issues. And they, you know, one of the myriad of things that was done is that they started to, separate from privileges and all these other kind of things, they would look at the activity on the database as a whole and look for anomalous behavior. So you're saying that in these data centers or these systems, there's nothing looking to say like, wow, you're going off to a really weird network address that we never talked to and suddenly downloading over time lots of things. There's nothing kind of monitoring in the hierarchy at the highest level what's going on.
No, no, it doesn't exist, and you've just described Axiado's business model.
Okay.
Right? So we want to make sure that because of the fact that now there's a new behavior after penetration, you can identify the problems and then solve them, because you don't rely on the data that the server gives you because the server is compromised. You would rely on the fact that the firewall would now see something like a constant exfiltration of data, right? That's what you would see. And so therefore, what we are trying to do at Axiado is build a firewall processor and a more secure BMC processor that detects when an attack is directed at the BMC and the data center, right? The servers, by the very definition, particularly with insecure BMCs, cannot possibly detect once they have been infected that they are infected. They can't, right? So you need something else in the infrastructure that allows you to see a change in behavior. And that's exactly what we're doing at Axiado, is behavioral modeling of the traffic and the type of stuff that's done inside the data center, right?
Alex just raised the hand. Alex?
Yes, I just wanted to mention that retroactively, there's been a lot of post-mortem activity done and analysis. It looks like these guys had sort of access or persistence on people's networks for a while, and they were moving very, very carefully under the guise of having the right access, right? So they were sort of encapsulated within a level of access that looked legitimate. So, and they did a good job of covering their steps. Now in hindsight, we can see that there were command and control centers set up for them to beacon out to and all these things. But in real time, it's really hard to catch some of this stuff. And they know how to move around so that they're not detected, right? If you can imagine that they have the sophistication to pull all of this off in the first place, they understand how to cover their tracks. So in hindsight, we know how they did it, but they did one of the amazing parts is how well they did all of this to not go detected for months. They were up to from between 6 to 9 months. They had persistence on the network.
Correct. And that's largely due to the fact that they were able to penetrate the servers without going through the server operating system's shell. They went in through the BMC.
So Usher raised their hand as well, and maybe after that we'll stop and just finish the presentation. Then we'll continue with.
Axel, I just wanted to just to have some comparison between, I guess, what was published and known. So when we refer to the Orion software, which is basically what SolarWinds was selling and installing on every client that was participating, where is that one in relationship to the things that you're talking about? Is that your OAMP, or because the knowledge was that everyone trusted one piece of software, Orion, that was running on a particular piece of hardware in their environment, and through an update system that went back through the Orion system, they managed to penetrate to the rest of the network. That sounded still controlled. That is not on every server yet.
I'll come into it. I'll come to that, but that's going in the right direction. So yes.
Okay.
Right. So I've just explained to you how this OAMP software, by the very definition, has to have access to everything on every server, switch, router, firewall, right? So that means that if you try to get into any operating system or any data center, you can do that one by one, but that's too much work. And most importantly, you will very likely be caught, right? If you do it through OAMP, then you won't be caught. It's very hard to detect. And that's the attack path. The problem is, how do you get in there? So SolarWinds itself, they defended themselves very well against all kinds of attacks. They were not breached directly. So there's no fault that you could assign to SolarWinds. There was nothing really that they did wrong, right? The attackers never penetrated SolarWinds themselves. So SolarWinds was not breached directly. It was breached indirectly. So what they did was they exploited the way that tools are built today. Usually, if you build any kind of tools, and particularly for Linux, it's open source. What you usually do is you build the tools using internal repositories. The internal repositories are usually protected, they're version controlled, they're signed. You've got full authenticity of the archive, everything, no big deal, right? That's not the problem. But there will always be external repositories. And it's not uncommon to see that a tool is built from thousands of different pieces of source code. In fact, if you look at the, FreeBSD is one of the smallest operating systems you can get into today. That alone is over 1 million pieces of source code. So the build script for building FreeBSD will fetch over 1 million files to compile them into the ultimate operating system. Linux is vastly bigger. If you build Linux, you pull about 20 million files, right? If you build a tool of the size that that Orion, which is the name for the administrative tool that was breached, that is very likely in excess of 1 million files, not lines of code, 1 million files that are fetched from internal resources and from external repositories. So these build scripts, they're usually very, very well protected because everybody knows you pull files from here, you pull files from there, and you try to only use things that are either under your control or at least authenticated and signed by others. But some tools and some files you cannot because it's open source. You don't know who the developer is, but you need it because, let's say, it's a crucial part of integration of any tool into the operating system, right? So what happens is you don't breach the build script. You don't breach the internal software. You don't breach any of that that is under control and that is authenticated by the tool supplier. What you do is and you can go one further, advance one slide, please. What you do is you pretend to be a developer and you compromise a file in an external repository. And then what you do is you pre-compile it so nobody can look into it. And then what you do is you simply put the non-malicious version of the file source code online, but the breached precompiled DLL online as well. And if you've got a build script and you need to fetch something that's on the outside, and let's say the DLL is fairly big, then you don't want to compile it. You want the build script to fetch the DLL because it's faster, right? So that's where the problem starts to arise, because you can't compare the source code to the DLL contents, and you can't look into the DLL unless you have a symbolic disassembler, and you do that for all of the 1 million files that you need to integrate into your tool that you're building, right? So what an attacker does is very simple. Pose as a legitimate developer in any repository, any project. The important part is that this piece of software has access to crucial data, like logins, like anything that is core to the operating system, right? That's what you pick. You modify it, you post it, and then you let it run its course. So you compromise the file, compile it, make it a DLL, or anything else that is a non-reviewable piece of software contributed to the repository. And upon the next time that this tool is being built, it will fetch it, and you have your backdoor. Go to the next slide. Right? So now you have a compromised tool set, you have a backdoor, or you have something that exfiltrates everything that is important. Either one works fine, no big deal, right? Now, at that point in time, you have access to everything and anything because you have access through the OAMP tool to the BMC that you can now exploit. And that means the entire infrastructure now is yours. It is yours. It is under your control. You can compromise anything, and you can make that persistent by not changing a software piece on a server. You can make it persistent by changing the firmware, by providing the credentials, the validated credentials that the OAMP tool gives you to update the firmware of everything in the infrastructure, any server, router, switch, and firewall. So now it's persistent because you have updated the firmware of all of these devices, right? So it's persistent. Even a reboot doesn't do you any good because the servers, the switches, the routers, the firewalls will start with compromised firmware. And so that's the second part in Axiado's business that we change. You cannot do that. It has to be authenticated, and there have to be other measures taken to make sure that an update is possible, right? We will still allow for OAMP tools to do it, but there is more to it. But anyway, so these attackers took the smartest possible path to compromise the largest number of servers with the least amount of effort to be done. And if done right, it leaves no traces whatsoever. None. Right? Okay, go to the next one. So the implications are pretty terrible, because even if you are well protected, even if you've got a firewall, even if you've got all the set of policies right, even if everything was done correctly, this breach is bad enough. You can be compromised and you don't even know about it. You don't notice it, you don't know it, and unless you look at every piece of firmware and compare it to the firmware that is on the on the server's manufacturer's website, you don't know that you've been breached. And that is terrible because it really leaves you no security. It leaves you no trust. You cannot trust your own infrastructure. None of it. So the problem is the attackers have everything and access to everything they want. You don't know if you're compromised. There is no easy way to find out if you are compromised. It doesn't mean that there are logs from the access and the compromised servers and the firewalls and the routers and the switches. So the target might never find out it was compromised. And it might leak data permanently because very simply, if they don't know they were compromised, they don't know that they need to clean up. And even if they know they need to clean up, they don't know what to look for to clean it up. So this makes it very, very nefarious because it really is totally under the radar. Even if you were compromised, you don't know that you were compromised, right? So yes, of course, Alex's assumption is correct. Zero trust is the right thing to do. You have to assume everything can be compromised, has been compromised, but the issue is, what do you now compare it to? So even zero trust doesn't quite help you because your entire infrastructure is compromised, right? You can't trust anything.
You can't trust yourself. You can't trust the
Exactly.
to do the right update. Whatever you think is right.
Yep.
No.
Correct, right? And so that's really why this is so nefarious. You don't know you were compromised. Even if you find out, you don't know how to remove it. And it's a hell lot of work, right? And you don't know if the OAMP tool is still compromised. And I'm pretty certain that even if SolarWinds says today, yes, we clean it all up, I'm not sure that that's the case because who knows how many DLLs they compromised, right? It might very well be that we found half of the compromised DLLs and they were removed. But if the other half persist, the new build will still contain all of the compromised code. Right? Okay, go to the next one. So in conclusion, really, this is one of the worst imaginable hacks ever. Why? Everybody must consider themselves compromised. Everybody who assumes to be compromised, and that's everybody, has to review its entire infrastructure. Every server, every router, every switch, every firewall. Everything, right? Even well-protected targets with very good security practices might be compromised. They don't know about it, right? So you have to act even if you assume you were not compromised because there's no easy proof that you were compromised unless you've got an uncompromised or known uncompromised firewall and you see in the log that there's ongoing exfiltration of data. And on top of that, now there's already multiple variants of this attack out there. Now the newest one is Raindrop. So Teardrop, Sunspot, and Sunburst, they had been found in the first 9 months after they first were infiltrated. And it took close to another 2 months to find the fourth variant, right? So who knows how many more are out there? We don't know it. I don't know it. I don't think SolarWinds knows it. The only people who know it are the attackers, right? So that's really what there is. And so this concludes my presentation, but this is a scary attack because the ramifications and the implications are pretty drastic. Right?
Axel, can we ask any questions?
Oh, sure, absolutely, yes.
Now it's the time.
Yes.
So the first one is the knowledge that you have about the depth of whatever happened, and we clearly talking about very large companies that were involved, anything from, you name, Microsoft to Cisco to many, many, many more. Do you have any general idea of how many potential servers are involved in the attack, or you don't know, just like I guess no one else does?
Yeah, I think we've got a fairly good idea of what the scope could potentially be. I can't tell you that that's a real number, right? So Microsoft, in fact, believe it or not, I'm usually not a fan of Microsoft, But Microsoft found it first because they saw unusual behavior and unusual traffic in their networks and in their data centers. So they think that their entire Mountain View data center is compromised. That alone is over 100,000 servers. Right.
So there were many conversations, including a chief security officer that was working for SolarWinds and quit 2 years before the attack, making the suggestions and writing reports that the way that they are protecting their infrastructure, including all the tools, was not sufficient enough, and he was not willing to take the responsibility for the fall before it happens. I mean, I don't know if that has anything to do. I mean, there's even suggestions that some of the code was written or developed outside of the United States, and I don't know if that was an entry point.
That's correct.
All of those indication of not doing a great job at SolarWinds or
well,
it's
okay,
just an unfortunate case.
So, I mean, you know, in hindsight is always perfect. I think the idea was that outsourcing software development to Ukraine is okay, right? And so SolarWinds did that about 3 years ago to cut cost. There's nothing wrong with Ukrainian software developers, right? From my point of view, it is very hard to detect an attack like this. This attack could have happened even if those same developers were in the US, right? So I'm not faulting SolarWinds. I'm not saying that the Ukrainian programmers were bad. I'm not saying they followed bad security practices. I don't think so. I think the issue very simply is whenever you have a piece of software that requires so much source code, and when the build script is including about 1 million files, then you know you're in trouble because there simply is no way to protect it anymore, right? You can't even authenticate everything because now you need to have authenticators of the authentication tokens. And you need to have people supervising the people who issue the tokens, right? So at some point in time, the sheer volume just makes it impossible to fix. And let me put it this way. If I had to breach it and I wouldn't have been able to get into the SolarWinds developers, guess what? I would have had a look, what is the version of Linux that SolarWinds uses? And I would have breached the Linux version, the operating system itself, right? And yes, Linus Torvalds looks at everything allegedly, forget it, he doesn't, right? It's impossible. It's 25 million lines of code, right? So forget it. He can't even look at the entire kernel anymore because the kernel alone is over 1 million lines of code. One of the reasons why we chose FreeBSD for Axiado was it is vastly smaller. So, you know, I had to look just for shits and grins. How does malloc work? How does free work, right? Both are less than a page when you print it out. Even I can verify, yep, looks okay, right? If your operating system kernel is, what was it, like 6,000 lines of code, I'm sorry, forget it, right? It's not possible. So I'm not putting blame on SolarWinds. I'm not putting blame on the fact that they were outsourced to Ukraine, right? At that point in time, I don't think anybody thought about an attack like this. I think it was very clear that that the attackers knew that a good portion of the software development was in Ukraine, and they used the physical proximity to very likely put a mole into that team, right? It could have happened here too. It's, you know, there is no absolute security. And that's part of why we're doing what we're doing, because there is no way to make anything absolutely secure. There's only a way to make it relatively more secure than any of your potential, even state actor attackers can assume, right? That's all you can do. There's no such thing as 100% security. It doesn't exist.
That's really tough. Why is it that none of the NOCs were able to see that servers getting firmware rewritten into their servers and rebooted, which they had to do? None of it was being recognized as a problem?
So most of the large-scale data center operators, they run statistics on firmware updates why they do it, when they do it, all that kind of stuff. And it looks like the attack was such that it was perfectly commensurate with a normal rate of firmware updates.
Well, it had to be, yes, because if I'm putting code that is going to be compiled into firmware, it's not about time. I'm not dictating when this firmware is going to be updated. Whenever it is updated, great, I'm in. It's not that as an attacker, I really care to when it's going to happen. So it wasn't time dependent. It was tool dependent. Once I can compromise a tool, I'm good to go, and I'm just waiting for it to happen. And the next time there's a new version of something in the operating system and it comes up, it just will come naturally. The owners of the system will say, yeah, this is exactly what we actually wanted to do. They don't know that it's compromised.
Yep.
Is this more dangerous now that we've moved to shared cloud services?
Well, in a way, yes and no. So yes, because one OAMP center now administers multiple million servers. So once you breach one server, one OAMP center, you're in, right? And you are in a lot of servers. Now, one can argue, and I always make that argument, that the larger the data center, usually the more people you have who follow procedures and processes, and where you have somebody to look at the security and the policies that were instituted to keep it safe and secure, right? Because if you've got a data center, like ours, we've got in essence, we've got one IT guy. And believe me, he's busy with the daily shit. He doesn't have time to read, oh, look, there was this kind of attack, there was this kind of attack, right? So I have to feed it to him. I have to say, hey, look this up, make sure we're protected against this, make sure this, right? So one can make the argument that large data centers have much, much better security because very simply, they can afford to have more people look after the security, right? That argument can be made. It may be as valid or invalid as any other argument to be made, but from where I sit, the large data centers are usually protected by professionals who know what they're doing. The smaller data centers, usually, they don't have quite the same level of security, right? And I'm pretty sure Alex can confirm that his customers will not put enough priority on keeping things humming and things secure. They will very likely always say, hey, make it work. Don't spend too much time on security because that costs us money that at this point in time is not necessary and we can't and don't want to spend, right? That's what we see.
One of the biggest fallouts, I think, from this that concerns, I think, some of us that work with smaller customers, SME, SMB, middle market, is that the idea is that now that they've done this and they've sort of gotten as much as they can out of the alphabet agencies, that they will then hand off this persistence to their smaller customers in that ecosystem to the ransomware gangs, and those guys will go to town. And that the fallout of be large for smaller entities now that are not put forward on security. So I think, unfortunately, we're in for another busy year with all of the stuff.
Yep.
Axel, I have a question for you.
Sure.
Based on the assumption that not only SolarWinds, but who knows what other MSPs were compromised, since it's easy. And what you're telling me is the BMC is legacy.
Correct.
So obviously we're trying to be in a new paradigm, trying to be secure when it's impossible because we still have one foot in legacy, and we'll never get secure as long as we have legacy.
Correct.
So we have to redesign the house, which means we have to redesign all the hardware, and we have to make sure that, look, Unix was written in the late 50s, early 60s. Do you think they were asked to leave a back door open? I'd say the odds are pretty strong that J. Edgar Hoover asked for that or whatever. We can't have that anymore. Mm-hmm. And right. Linux is the winner. So how do you redesign this house?
Okay, so two things. First of all, Linux isn't quite Unix. And second, if you look at any of the modern variants of Unix, FreeBSD, NetBSD, OpenBSD, internally we use that because it's more secure. We have done code review. We did not find a single backdoor in FreeBSD, right? So I'm pretty sure that FreeBSD is about as secure as it gets. Can I rule entirely out that there's a backdoor? No, I can't, because I haven't reviewed the entire code. But I can tell you that everything we have done indicates that FreeBSD, NetBSD, OpenBSD, there are no backdoors, right? Linux is different because Linux is a wannabe Unix variant. It won in the backbone, I totally agree. The entire internet is made up of Linux. The only notable exception is Netflix running FreeBSD, right? So actually NetApp also, all of the NetApp appliances, they're running FreeBSD or a modified variant thereof, right? So I think the use of more secure operating systems is incumbent on us, and we have to make sure we're getting to that point where the operating systems are more secure and the hardware, particularly the legacy stuff with the old insecure BMCs, goes away, right? So that's the basic premise for my company, for Axiado. We want to say to all those guys, hey, there is a more secure version of a BMC, and we're doing all kinds of stuff, including behavioral monitoring of all of the IO going in and out from an administrative purpose and from that point of view, right? So that's what we're doing. But of course, we can't force any of the users to use an operating system such FreeBSD, even if they're stuck or even if they deploy Linux, right? Linux is already vastly better than what Linux was 10 years ago, and Linux is vastly better than anything that Microsoft did, right? So there's no doubt about that. That's already much, much better, which is of course why the attackers chose the path that they did, right?
So there's one thing that runs in my mind while you guys are talking about Linux and Unix and other things. One thing that runs into my mind that I think is a concern for some of my clients, for a few of them actually, is blockchain. So within the blockchain system, if you compromise one system, it's a no-brainer. You can compromise one, it's not a problem. When you compromise a full data center, you can have a coordinated attack, meaning the compromise can be as such that a specific transaction will be approved by all the servers as legit while it's not.
Yes.
So I just undermined the entire story of blockchain. Like it's just out the window. So now we need to completely distribute blockchain around the world, and it cannot be in a single data center. But I'm aware of huge data centers that are specifically for blockchain. That's the only thing they do, and they're single, like managed by one OEM system. They are not being managed by 55 others. Okay.
Right.
So as far as I'm concerned, this is a big no-no, big issue, big opening right now that we have in the financial industry that I was not aware of before.
Yeah, I think a lot of banks were not aware of the fact either, but yes. So I got a question with regards to if there's any evidence that in fact the BMC was the entry point. Yes, there's plenty of evidence. I'm not allowed to share all of it. Some of them I'm allowed to share, but I can tell you that the evidence we have points to the BMC as the entry point. Maybe not for all variants. Maybe I haven't read up on the just newly discovered one, but the evidence we have for the prior three points to the fact that the BMC was used as the entry point.
Basically, what I'm trying to tell to the people on the call, and thank you, Axel, for this, for that comment. Try to tell people on the call, if you have money in a bank, usually you've got also some kind of insurance and security associated with money in the bank. When you have money in blockchain, if it's gone, it's gone.
Yeah, and if you lose your password, it's gone too, right? So that's the way it works.
Yeah, think about it. Oh no, somebody can actually take away your password and actually change it right now and own your wallet. Just be aware.
Right, and so that's why the exchanges are always the vulnerable parts and not your own. Even if you have perfect security, right? I would never be so stupid to attack a user and a wallet of a user of Bitcoins, right? I would always you go where the money is, right? That's what bank robbers do. They don't rob 100 houses. No, they go to the bank.
Yeah.
Right? It's twice as hard to rob a bank as it is to rob a private residence, but you have 100 times the return,
Yeah.
right? If not more. So yeah. But
Brooks, Nicole, I see your hand is raised. Did you have a question?
Axel, generally, I'm a glass half empty kind of guy to start with. So what you're telling me is turning my world a little upside down. With the assumption that you have no way of knowing that you've already indicated, and that you have no way of actually checking, and I'm not sure that statement is absolutely true. With my focus on the smaller guys, we're talking about people who have small data centers or have 1 or 2 servers, and you're telling me that their firmware may be compromised at this point in time.
that's correct.
Do they have any action that they can take? I mean, you already said it. We're talking about guys who don't have a budget to swap out a server, or they don't have an IT infrastructure that can manage that sort of thing. What's the plan of attack here?
So I'm paranoid in the first place, right? So what I did for every single server we have, as soon as we buy it, I copy the firmware from the manufacturer onto a secure disk, and that is in my possession. So what we did, because we couldn't verify or falsify that we were attacked, we simply reflashed a known good firmware onto every single server and firewall.
And then the next logical thing is reinstallation of the OS.
That's correct. That's what we did.
Wow. Okay.
From an older or from a version that you know was not compromised, that you have in your possession. You can't actually reach the web and say, oh, I just download a new Ubuntu version and hope that it's not compromised.
Correct. So once you download it after the attack, you're screwed, right?
Yeah.
So yeah.
Or at least after a known attack. And this is a known attack.
Yes.
The question is right now, which are other attacks that may have been done in the last few years that we don't even know of?
Correct.
In exactly that way. This is kind of like an ideal way to attack system.
Yeah.
It's funny to go to Excel's IP portfolio and
After
and see that.
So and then you've got classic Linux dependencies. You can't just pick one because you'll destroy your entire installation.
Yeah, tell me about it. I've been there, done that. You go back one version with a different version of PHP, and all of a sudden, a lot of stuff doesn't work anymore.
Right.
Many tools will just stop working. My Android simulator on this computer is not working because I did an upgrade 2 days ago. It's just not, and I don't know how to fix it. I have no idea how to fix it. And I'm good in Linux. Trust me, I'm really good at Linux. I read source code on Linux.
I wouldn't admit that if I was you, but
I'll figure it out. I spent only an hour on it, and I was like, you know what? My time is worth more money than me spending time on it. I'll just wait for the next word.
Okay, I just got a new. Okay, my fire.
Okay, gentlemen, unless there are more questions and more concerning things. By the way, you know how to reach Axel. He is also on our website. If you have questions and stuff, I'm assuming he will be open to answer. He's super guy. I mean, I know him for some time, and this is my go-to for security. Nobody else that I'm aware of, and I know many. But thank you, Axel. This was an awesome presentation.
Great.
Any more questions?
Yeah, I've got one for Axel.
Brilliant.
Axel, so we have this problematic infrastructure that's going to be with us for some time. You were saying a lot of the normal tells weren't helpful here, like modifying or turning off a firewall, for example. So are there any hallmarks or things that companies, while they're trying to sort through this, any signals that you find helpful to look for?
Yeah, some of them, and that goes back to a question from Andrew. So yes, I agree. Most of the literature you find from FireEye, Microsoft, and others, they in fact do indicate that keys were stolen, but they don't indicate how they were stolen, right? Because usually you don't have access to private keys anyway. So we can get into more detail, but what I would encourage everybody who thinks that they might have been compromised is look at set up firewalls, every firewall that you have, to not be administered by Orion or any of the other OAMP tools. Disable the ability of the firmware to be updated after you have updated it to a known good version. And then look for exfiltration, because usually there will be some exfiltration, right? Because otherwise, if you can't get keys or anything out of it, then what's the point of penetrating a system? So look for any kind of unusual exfiltration of data. And a lot of, believe it or not, a lot of firewalls don't allow you to do monitoring of exfiltration. They only look at data coming in. So one of the things we did early on was we use pfSense. pfSense is an open source firewall that uses both snort rules and also squid guard. That can be used in full duplex bidirectional mode, and you can see and monitor everything that looks like anything gets exfiltrated, right? So set a rule that says if something that is not HTTP or any of the protocols that you use, if anything goes out through a port that is not associated with any of the ports that you usually use in your normal business, then flag it and immediately drop all the connections to this particular device that it's exfiltrating to, and block that not only IP address, but port number in general, right? So that would be my advice. And in fact, we've been doing that for quite a while.
Great.
Beautiful. I don't know if you guys got a chance to read what Andrew was sending, and Max, your video just went out of business. Max, Brooks. Andrew is sending all sorts of beautiful notes to everyone if you want to read them, unless you want to jump in and say those things.
Yeah, I'm sorry for not sharing the audio, but sometimes the question comes up as other topics are going on, and it's easier just to get them written down in the queue that way. But no, if I understand you correctly, Axel, excuse me, you're not disagreeing that the private key that signed the tokens that allowed remote access to email and files and whatnot happened. You're just saying that the BMC was the route to that key compromise, perhaps, or
that's correct.
And yeah, that's very interesting. You know, anytime you have these high value targets, right, whether it's static source code or static keys or you know, anything that sits there as a non-moving target for months at a time, I think, yeah, you know, from a protective point of view, that's a real challenge, right? And there's no, I think, one silver bullet that's going to solve everything. But I look forward to learning more about your technology. You know, we come at it from our company at a different angle, but you know, it's going to take more than one solution to address all of these different creative attacks the bad actors are launching. And thank you for the talk, and also for this forum, right, where we can not just, you know, connect to you know, to talk about our own company's technology, but this is a problem that we as an industry need to move jointly together to solve, because there is no silver bullet.
Correct. I totally agree.
And I'll hop off my soapbox now.
Yeah. No, I mean, so that's why I said in the beginning, right? If you want security, you have to have not only the hardware, firmware, software, but also policies and procedures in place, because you can have the best hardware, software, firmware security. If your policies don't work, there will always be the social engineering part, and exfiltration will happen through that, right? So I totally agree. There is no one silver bullet that is the single solution to the problems. It is just that if the underlying foundation isn't working, then you can do whatever you want on top of it. It will always be very easy to breach, right?
Indeed, and I think the recent breaches that we've seen have shown us a number of cracks in the foundation that we've built, you know, across a variety. I mean, just TLS on its own, used to secure most of the data on the internet, is a 30-year-old protocol at this point. Right? And it has quantum vulnerabilities as well as these static keys that we were talking about.
Yep.
These are issues that need addressing.
I agree.
And you know, this is kind of like part of the subjects that we are discussing on this technology roundtable, and this is what we wrote this presentation. We are concerned with undermining even the weak security that we already have being undermined by legislation and by decisions that and by people making the wrong decisions, even though they think they're informed and knowledgeable, they open all us up. In this case, as far as I'm concerned, there are plenty of large corporations with more data about me than I have about myself.
Yep.
I mean, it's not necessarily that you guys know everything about me, but there are places where if you could get to, you would know more about me than I know about myself. And this is kind of like mind-boggling. I don't want people to analyze data and realize that they can be me, mimic me or do anything else and so forth. It's just, we just moved on the privacy to such an unknown territory, and at the same time we know about breaches that now export and expose all this data. So I'm not paranoid. I think I'm, you know, okay in the world, but at the same time, it's kind of like eerie to look at.
That was a nice segue into next month's topic, Shmuel.
Yes, which is privacy.